This video will explain the electron configuration, so it's the electron arrangement for the noble gases, and why that configuration is so important. So as you can see, I've got down the top three in the group for the noble gases. Helium has got 2 electrons, the atomic number here is 2, that means it's got 2 electrons, and those 2 electrons are in the first energy level. I've then got neon, so neon's got 10. 10 is arranged 2 in the first energy level, 8 in the second. And then argon's got 18, so that's 2 in the first, 8 in the second, and 8 in the third. Now if you look at those, you should be recognizing that the outer energy level in each of those elements is full. So the first energy level can hold 2, and it's got 2. Second can hold 8, and it's got 8. And the third can also hold 8, and it has 8. So the fact that these outer energy levels are full makes these noble gases very special. These noble gases, we say, they have a stable electron configuration, electron arrangement. This means that they are unreactive, and the chemistry word for that is, we say, they are inert. So inert is unreactive. Okay, now all the other elements in the periodic table are trying to achieve this full outer energy level. That's why they're going to take part in chemistry, and they're going to either gain, lose, or share electrons in order to do that. So for example, let's give you an example. If we had sodium is 2311, okay? So sodium's atomic number is 11. That means the electron configuration is 281. That's not a stable arrangement. 1 electron in the outer energy level makes it not stable. So it needs to do something about this. It can either gain 7, which is quite difficult to do, or it can lose 1, and losing 1 is much easier. So it needs to lose this 1 electron, and when it loses that 1 electron, it does become, it stays a sodium, but we're going to come back to what type of sodium it's going to be, and it becomes an electron arrangement of 2,8, which is a stable electron arrangement. It's matching in neon. Now that causes a change, because at the very beginning of this, sodium has 11 protons, and it had 11 electrons. Now if you remember, protons are positive, electrons are negative, so you have 11 positives and 11 negatives. Overall, you have no charge. But if you look on this side, we still have 11 protons, but now with 2,8 losing that 1 electron, it has 10 electrons. Remember, these are positive, these are negative. So if you have 11 positives and 10 negatives, overall, you have a +1 charge. So that means when this sodium atom has lost an electron, it forms Na+, and this is a sodium ion, and with the stable electron arrangement. Another example, just to illustrate this, we'll have a look at a negative ion. So let's have a look here at chlorine. Chlorine is 35.517 Cl. Okay, so 17 electrons, they're arranged 2, 8, 7. Again, this is not stable. This needs to have 2, 8, 8 or become 2, 8. So it either needs to lose 7 or gain 1. It's easier for chlorine to gain 1 electron here, so this becomes 2, 8, and that's what it's going to do. So chlorine is then going to become Cl with an electron arrangement of 2, 8, 8. Remember at the very beginning, chlorine had 17 electrons and it has 17 protons. Protons are positive, electrons are negative. 17 electrons are negative, overall 0 charge. Once this has gained this electron, it still has 17 protons, because protons never change. They're positive, but now it has 18 electrons. And 18 electrons that are negative against 17 protons mean it has a -1 charge overall, and that would go here to make this a chloride ion with a negative charge.